In this video, we're going to go over Newton's laws of motion. We're going to understand the different kinds of forces that exist and also being able to determine the acceleration when it comes to the second law of motion. Okay, so what basically does the first law of motion state? So the first law of Newton's laws states that an object that is at rest or moving at a constant velocity will continue to do so unless an external force is applied. So we have two scenarios where you may have an object that is at rest or moving with constant velocity. Okay, so either of the two situations, the object will remain in either of the states unless or until you get to apply an applied force, which we're going to call an external force. Okay, so that's what basically first law tells us. An object at rest or an object moving with constant velocity will continue to do so until applied by an external force. Okay, so that is an assumption of first law of motion. What does the second law tell us? So the second law tells us to say that the acceleration that results from the force applied is directly proportional to the force applied. So this basically gives us this equation: force is equal to mass multiplied by the acceleration there. So basically what we are saying is the force applied is directly proportional to the acceleration. Okay, so what does this mean? So this means if, let's say, you have a force 40 newtons, then you have a mass maybe 2 kilograms. Okay, so if you find the acceleration there, you divide by 2 on both sides. Your acceleration is going to be basically, that will be a 20 meters per second squared. So what happens if you increase the force? Let's say maybe you make it 80 newtons. So with a same mass of 2 kilograms, so you divide by air again, this time around it will be what? It will be 40 meters per second squared. So that is basically what we are saying about the second law of motion. But then the mass is inversely proportional to the acceleration and what? And the force. So this is what we are saying. So talking about the same mass, let's say we have 40 newtons, then we have acceleration of let's say 20 meters per second squared, then we don't know the mass. Okay, so what happens there? Or let me put it this way: let's say we have the same mass of 2 kilograms. Okay, then you have your acceleration there. So if you try to find the acceleration there, you're going to have 20 meters per second squared. So what happens if we get to increase the mass with the same force 40 newtons? So the same force 40 newtons, we increase the mass, let's say we double it to be 4 kilograms. So in such a case, the acceleration is going to be what? It's going to be reduced. And that's what we mean. So basically what we are saying in summary for the second law of motion, the basic relationship that is there is force is equal to mm. So when you increase the force, acceleration is also increased. Okay, but when you get to increase when you increase the mass, the acceleration is what? Is reduced. So what is the basic relationship that is there when you talk about the second law? So how about the third law? So the third law of motion tells us to say that for every action force there is an equal but opposite reacted what? Force. So if you apply an action force on an object, there is an equivalent what? An equivalent reaction force that is applied. So this basically explains why if you punch in an ore, you're going to feel a pain. So you hit in the ore, you're going to feel a pain. Why? Because the force that you've applied there is being applied back onto you. So there's an applied force as well as what? As well as a reacted force. Okay, so that is the way it works. So this explains why if you look at something that is placed on a level ground, okay, so there is a weight that is acting downwards. So due to that weight that is downwards, the ground is also going to apply what we call a normal force on that object upwards. Okay, so now let's try to understand the different kinds of forces that we have. Okay, so we use this diagram to help us understand. So let's say you have this object that is on a level ground and you apply a certain force to the right hand side. Okay, so this force that is applied, we call it an applied force. Okay, so there is no need of us explaining what an applied force, because basically the name says it all, applied force. So this is actually just a force that you've applied on an object in a certain direction. So of course we need to understand that the forces can either be a push or a pull on an object. Okay, so the other kind of force that we have is the weight force. So the weight force is a result of what? Is a result of gravity. Okay, so it pulls downwards. So it's a result of gravity. So now from the third law of motion, we are told that for every action force there is an equal but opposite reacted force. So there is a force that supports the object on either a table or the ground. So we call that the normal force. Okay, so that is the normal force. Then in some cases there are some frictionless surfaces where there is no friction, but there are some cases where there is friction. So friction is actually a force that opposes motion. So if you're applying a force to the right, there is a force that is opposing that movement. So we call that friction force. So friction force is a force that opposes motion. And the friction force is dependent on the normal force. So friction force is basically given to be equivalent to the coefficient of friction multiplied by the normal force of that object. So we'll get to understand that we have different normal forces depending on what you're talking about. The normal force of an object that is on the level ground is different from a normal force of an object that is on an incline. So we'll get to talk about all those different situations. Okay, so now let's try to understand one thing here. I'll draw back the box that we have there. So I'll draw it here. So now let's say you get to apply a force this direction. You apply a force. Okay, then there's no friction on this surface. Then of course we understand that this has got a mass. Okay, so let's try to resolve the forces that we have in this case. Let's say they ask you to find the acceleration. So what you're going to do is, of course, you know the acceleration from the second law. We know force is equal to ma. So you being given the force and also the mass, you're able to find what? The acceleration. Okay. Okay, so what would be the next thing that we can talk about again? So now let's say we change something about it. Instead of just being a force applied, now we get to have maybe a friction force. So let's say we have a friction force on this very surface, meaning that this surface is kind of rough and it's opposing the motion. How do you get to determine the acceleration of that body? So in such a case, we know that there is what we call a net force. So a net force is basically the force that gets to cause acceleration of an object. Okay, because not every part of the applied force leads to acceleration. In some cases where there is friction, part of it is used to overcome what? To overcome the friction. Then the other part will now be used to lead to acceleration or increasing the velocity of that object. Okay, so now we have an applied force here, then we have a friction force that is opposing at that point. So how do you get to find the acceleration of such an object? So we're going to say, okay, the net force is basically what will lead to acceleration, but the net force is basically going to be equivalent to the force applied. We subtract the friction force because part of the applied force is overcoming the friction. So the applied force is going to be reduced, and what is going to remain is what we are going to call what? The net force. So the net force is basically the product of the mass and what? The acceleration. So if you plug in that formula, we have mass times our acceleration, then we have our applied force minus the friction force. So we say the friction force is actually given as a product of the normal force and the coefficient of friction. Okay, so in this case where you have a level ground, the normal force is basically equivalent to the weight going downwards, so which is mg. Okay, so let's try to simplify this formula. We see where it's going to lead us to. Okay, so our goal is to find the acceleration there. So basically our acceleration is going to be equal to the force applied minus mu k multiplied by the mg divided by what? Divided by m1. That is basically the way you're going to find your acceleration. So this is just like an introduction of what you need to know under Newton's laws of motion. So I've got a number of questions that are going to help us understand more in details. Okay, so question 1. The two blocks 2 kg and 5 kg are connected on a horizontal frictionless table and put to the right with a force of 40 newtons. Calculate the acceleration of the masses and the tension T in the chord connecting M1 and M2. So basically under the types of forces, there is what I forgot, tension. So tension is basically just a force that acts in a cord or a rope. Okay. So let's try to get into this now. So we have two scenarios where there is no friction and also where there is friction. So we are supposed to find the acceleration and also what? The tension in both cases. So what we have is we have a horizontal frictionless table. Let's try to draw that. Okay. Okay, so we have something like that. We'll consider that to be our table, horizontal table there. Then we have two masses. We have a 2 kg mass and also a 5 kg mass there. So these are connected. Okay, two blocks are connected. Yeah, they're connected. So there's a cord basically that is connecting, and this cord is massless. Okay, so what is the mass of that? That is 2 kg. Then that is 5 kg. So we have the masses there. Then we also have an applied force of 40 newtons. Okay, so the first question is find or calculate the acceleration and the tension. So we have to come up with a relationship that is going to basically help us to solve this question. So how do we go about it? Okay, so we're going to study these masses one by one. So I'll let the small mass be M1 and the other one be M2 to start with. Okay, so what did we say? We say that the net force is basically the force that leads to what? To acceleration. So the net force is basically given by the force applied, subtract what? Subtract the opposing force. So what we are saying is the force that you have applied there is basically overcoming something that is opposing it and also leading to acceleration, which is the net force. So the difference between the applied force and the opposing forces gives us what we call the net force. So starting with answering the first question where they are saying there is no friction. So meaning that the only force that is opposing motion, and in this case what we have is a tension. Tension is acting along this rope. So this tension is causing this mass to move, this mass M1 to move, and also trying to reduce the acceleration of the first object because it is kind of putting it a bit backwards. Okay, so that is our tension in such a case. So starting with the first object that we have there, 5 kg mass there, if you look at it, so the applied force there is 40 newtons. That is what is making it to move, and we've indicated it in the formula there. So now we are going to remove or subtract the opposing forces. So the opposing forces that we have in this case, we only have what? We only have tension. So subtract tension for the first object. So we say the net force is basically the product of mass and acceleration. So the mass of that object is basically m2. Then we don't know the acceleration. So we say equal to the force applied minus the tension. So that is our first formula. We can now look at the smaller mass there. So if you look at the smaller mass at that point, what is making it to move to the right? It's basically what? It's basically the tension. So of course what we'll say is the net force. We work with the relationship of the net force. So we have the net force. The net force is the product of the mass. So the mass is basically m1. Then we also don't know the acceleration, but it's supposed to be equivalent to what? So what is making it to move to the right is basically the tension that is acting along the rope. So we have the tension. Is there any force that is opposing it to the left? So in this case we don't have any force opposing to the left. So what are we going to say? So what we're going to say is there is nothing there, so minus 0, so which is basically just that. So we've come up with two equations that can help us get or find the acceleration and the tension. So the second equation basically is telling us to say that the first mass, smaller mass 2 kilogram, is only affected by the tension, which is making it to move, and there is no opposing force. So getting that value of our tension, you can plug it in the first formula there. So if you plug in, what are we going to have? So we have M2A being equal to force applied. So our tension is basically equivalent to M1 multiplied by what? Multiplied by A. So our goal is to find acceleration, so we can make it to be the subject of that formula. Okay, so we have M2A on the left hand side. This can go the other side, it will be plus M1A equal to the force applied. So at that point we want to factorize what? The acceleration. So we have M2 plus M1 being equal to the force applied. So if you make your A to be the subject there, you have the force applied basically being divided by M2 plus what? Plus M1. That's what we have as our formula for the acceleration there. Okay, so now you can just now plug in there and you'll be able to find your answers there. So therefore our acceleration is going to be, the force applied in that case was 40. The masses, we have 2 and 5. So we have 2 plus 5. So basically you have 40 over what? You have 40 over a 7. So what happens if you subtract that? If you divide 40 divided by 7, 40 divided by 7, and basically what we have as our acceleration is 5.7 meters per second squared. Okay, so after finding our acceleration, what else do we have to find? So we have to look at now the concept of the tension. So we said the tension was actually equivalent to M1 multiplied by A being equal to the tension. So you plug in there at that point the acceleration that we found. So we know the mass of M1 is 2 multiplied by 5.7. Basically, what value are we going to get after multiplying? So our tension is basically 11.4. So tension is a force, so we use newtons. Okay, so take note of the acceleration that we found there. It's 5.7 meters per second squared in the first case.
So for the second part of the question, we've been given the coefficient of friction. So what are we finding? We're finding the acceleration and also what? The tension. So if the coefficient of kinetic friction between the masses and the surface is 0.4. So let's try to show these forces. So in this case we have a force applied, which is 40 newtons. Then we have a tension. So this tension is opposing motion for the first box and also making the other one to move. Then we also now have the force of friction working against both of these blocks. Okay, so we'll start just as we did in the first part of the question.
We'll start first of all by looking at the first box there. So I'll start with 5 kilogram box. So we said the net force is basically a difference between the force that you've applied minus the opposing forces. So if you look at the first box, our main forces are opposing its motion. So there is first of all the tension, as well as what? As well as the force of friction. So the tension and the force of friction. So there are some things that we can substitute in at that point. So let the mass of this box be M2. So that for the first one, smaller one is M1. So basically its net force is going to be given as a product of its mass multiplied by the acceleration. Then the applied force, we just leave it the way it is. For the tension, the way it is. Then for the force of friction, we said the friction force is given as the coefficient of friction multiplied by the normal force. So whenever you have something on a horizontal surface, the normal force is basically equivalent to the weight, because the normal force is basically provides support. Okay, so normal force in such a case is equivalent to what? To mg, which is the weight. So we have mu k multiplied by, so its mass is m2, then g. Okay, so this is basically the equation that we have for the first box. So now if you go to the second part of the first part of the box, which is 2 kilogram there. So for that one, what do we have? What is making it to move to the right is the tension. So say its net acceleration, or its net force, which is basically the product of its mass multiplied by the acceleration, is basically going to be what force is making it to move to the right. It's a tension. Any opposing force, in this case we do have one, which is the force of friction there. So we've shown it there. Okay, so basically let's try to make the tension the subject so that at least we're able to plug in the first equation. So the tension is basically going to be equivalent to m1a plus the force of friction. So we've moved the force of friction to the left hand side. So if you go back to our first equation there, we now substitute in. What basically are we going to have? So let's have some space. Okay, so I'll start. So on the left hand side, we'll maintain what we have in the force applied. So at the point where we have tension, now we can plug in this. So we have minus m1a minus, so its force of friction as well is going to be given as its coefficient of friction multiplied by its mass multiplied by gravity, which is a normal force. Well, so at that point where we have force of friction, I'm putting this. So we have minus mu k m1g, then basically we'll put what we have for that, minus mu k multiplied by m2g. So our goal in this case is to find the acceleration first of all, because tension is not in the equation. So what happens if we make our, how do we get to make the acceleration the subject? So this one can go the other side. So we now have m2a plus m1n. So on the right hand side, we're remaining with a force of friction. Then at this point, mu k and g are common, so we can factorize mu k and g. Then for the first part, we remain with m1 plus m2. So what we've done there is we've just factorized. So making our acceleration to be the subject in this case, what basically do we have? So our A is basically going to be force of friction minus mu k g m1 plus m2 divided by what? Divided by, so on the left hand side, what we are factorizing is A. So if you factorize A, what you are going to remain with is m1 plus m2 in brackets. So we'll divide both sides. So we have m1 plus m2. So basically that is the equation that we've come up with, and we can now substitute in and see the value that we're going to find for acceleration. Okay, so our acceleration is basically equivalent to, so this is basically the force applied, not force of friction. So the force applied was basically 40 newtons. What is the mu k? So our coefficient of friction is basically 0.4. Our gravity is 9.8. So if you open the brackets, our mass 1 is basically 2 plus 5. So we are dividing by m1 plus m2. So m1 plus m2. Okay, so what is our m1 in this case? So our m1 we are saying is 2 plus 7. So if you get your calculator there, 40 subtract 0.4 multiplied by 9.8, okay, multiplied by 2 plus 5, which is a 7. So basically what I have is about 12.56 divided by 7. Okay, so I'll do that again. So 40 minus 0.4 multiplied by 9.8 multiplied by 7, 12.5. Okay, so the same figure, then divided by 7. So what I have is our acceleration is basically 1.79 meters per second squared. So if you compare these two, you're going to see that they're very different. Okay, so why do you think the acceleration is lower in a case where you have friction? So it is lower because there are a lot of opposing forces, the tension together with the force of friction on both of the masses. Okay, so on the other hand, finding the tension is basically going to be given as, you look at this formula. Okay, So what was our mass 1? Basically our mass 1 was basically what? Was 2. So we have 2, our acceleration is 1.79 plus the force of friction. We said is basically the coefficient of friction, which is 0.4 in this case, multiplied by what? So coefficient of friction multiplied by the normal force, which is the weight in this case. So what is the weight? The weight is going to be 2 by 9.8. Okay. So get your calculator and plug in there. So we have 2 being multiplied by 1.79 plus 0.4 multiplied by 2 by 9.8. So basically our tension that we have in this case is 11.42 newtons. Okay. So what's the question that we've answered in this case? So if you look at the tension that we found in this case in comparison to the first one, remember the first one, what did we say about the tension? So we said the tension was basically equivalent to M1 multiplied by the A. So which was basically 5.7 multiplied by the mass, which was 2. So which is basically the same. So the tension does not change. The next question says, two masses M1 and M2 are accelerated uniformly on a frictionless surface as shown in figure given below. The ratio of the tensions is what? Okay, so we're trying to find the ratio of the tensions in this case. So basically we just have to come up with a relationship that is going to guide us. So I'll start by looking at my M1 there. So if I look at my M1 there, my question is, what is making it to move towards the right? It's basically the tension, right? So what we said is, we said in general the net force is basically given as the force making it to move, which we are basically saying the force applied, minus the opposing forces. So if you look at the first mass, is there any opposing force to the left? There is nothing. Okay. So what you're saying is the force applied is basically equivalent to the net force. So the net force is the mass multiplied by the acceleration. Then the force applied in this case, it is basically the T1 that is making it to move to the right. So if you go to the other box or the other mass there, what are we saying? What is the net force? Its net force is basically its mass multiplied by the acceleration. Then what is making it to move towards the right? The force applied is T2. Is there any opposing force? Of course there is, the tension one there. So the tension one is opposing its motion. Okay. So basically what we want to come up with is, we want to come up with a ratio of T1 and T2. So meaning that we don't want to see the tension 1 appear in the other equation. So basically let's find T2. So if you make T2 to be the subject in this case, it's going to be equivalent to what? So our T2 is going to be equivalent to M2A plus T1. So I've only moved the other part there to the left hand side. Okay. So that's what we have. So we have our T2 equivalent to that. But we also know that our T1, which we don't want to appear in that equation, is basically equal to M1A. So therefore our T2 is equal to M2A plus M1A. Okay. So what is the equation showing us our T2? So we also have our T1 there. So coming up with a ratio is it's not going to be a very big deal. So you just have to plug it now. So therefore you'll say, okay, my T1 divided by my T. So my T1 basically divided by my T2, which is our ratio, is basically equivalent to what? So what do we have? So for our T1 we have that. So we have M1A over our T2, we have M1A plus M2A. So basically that is our ratio. We can even simplify it further by factorizing what is common on the left, on the denominator and the numerator. So we have our A. So we have our A. So we have M1 on top divided by. So on the numerator, on the denominator, we can factorize our A as well. So we remain with M1 plus M2. So these will divide. So basically, in summary, our ratio is just going to be M1 over what? Over M1 plus M2. So that is our ratio, and that's how you approach that question. Okay, we are on the next question, a different case, which requires you to pay very much attention. So a 2 kilogram mass pressed on a smooth level table. So we have a table where it's smooth. So what are they saying? So it's frictionless, there's no friction, to a 5 kilogram mass hanging freely, as we can see. So it's hanging down there over the edge of a table as is illustrated. Calculate A, the tension, B, the acceleration. Okay, so basically, if you look at this question, how do you get to approach it? Okay, so you have to resolve the forces. You have to understand the forces that are acting on these different masses. So if you look at the mass 5 kilogram, how many forces are acting on it? So we have the tension there that is supporting it upwards. Then you also have the weight force there, which is mg, making it to go downwards. So there's no friction in the air. Okay, then if you talk about the one on top there, we've also been told the surface is frictionless, so there's no friction. So meaning that there's no force pulling it towards the left, there's no force. Okay, but there's a tension making it to move this direction. Okay, so these are the forces that we have. So now, considering the direction of where these guys are moving, so we are going to take an assumption to say they are striding downwards. This is going downwards. So the moment it starts going downwards, we'll say it has got a net force, making it to accelerate. Then even that one will also have its what? Its net force. So coming up with our equation, I'll start with the one that is on a table there. So we want to come up with our net force relationship. So what is making it to move towards the right is what? The tension. So do we have any opposing force in this case? There is no opposing force because there is no friction. Okay. So what is its net force? Its net force is going to be given by its mass. So its mass is 2. So we have 2. Acceleration we don't know, equal to our tension there. That's basically what we have for our first equation. If you go to the second part of the system, which is the 5 kilogram mass there, so our net force, its net force is basically going to be 5a, because the net force is the product of the mass and the acceleration. So what is making it to go downwards is the weight, which is mg. What is opposing is the tension, which is acting upwards, so minus tension. So basically, if you're able to come up with these equations, then everything is going to be simple. So the first part of the question is saying, find the tension. How do we get to find the tension? So we have two equations there. Want to find the tension. Okay. So I can make A to be the subject in the first equation there. So I can now create some space there. Okay, so if I go back to my first equation there, 2a is basically equivalent to t. So I'm making A the subject is t over 2. I can now go back to the second equation where I can plug in at the point where we have A. So where there is A, I'm going to put t over 2 being equal to mg. So where there is mg, the mass of the second one is 5, gravity is 9.8, minus tension there. Okay, so my goal is to make tension the subject. So the t can go the other side. So for this part, what do we have? We have 5 over 2 t plus t now coming from the other side, 5 multiplied by 9.8. So at that point we can factorize out our t. So factorizing our t, we have 5 over 2 plus 1 equal to 5 multiplied by 9.8. So we can add what's in the brackets there, 5 over 2 plus 1. So basically our 3.5 there. So our t is going to be 5, 9.8 divided by 3.5. So 5 multiplied by 9.8 divided by 3.5. So basically what we have is 14 newtons as our tension acting along that rope. Then how do we get to find the acceleration? So we can go back to the first equation there. So we have 2a being equal to t, 2. So our 2a is basically equal to what? To 14. So dividing by 2, our a is going to be what? It's going to be 7 meters per second squared. So that is how you approach a question when you're given such a scenario where there is one that is suspended and one is on a table. Okay, let's look at another practice problem again. So in this case, a 40 kilogram block on a level frictionless table is connected to a 15 kilogram mass by a rope passing over a frictionless body. What will be the acceleration of a 15 kilogram mass when it is released? So 41 is the one that is on the level table there. Then another one is 50 kilogram there. So even here we'll take an assumption to say it is going downwards. So what is basically going to make this system to be going downwards is due to the pull of gravity, the weight there. So then what is making this to go this side is because of a tension. So then for the box that is going downwards, there is also an opposing tension there. Okay. So now we can come up with equations as well. So starting looking at the first one there. So our net force, its net force is basically going to be given as what? Its mass multiplied by the acceleration. And we say the net force is basically the difference between the force applied, which in this case, which is making it move, is a tension, minus the opposing forces. So since it's frictionless as well, there is no opposing force to the left. So that is basically the only equation that we have for the first part. If you go to the second part, its net force is going to be given as its mass multiplied by the acceleration being equal to, what is making it to go downwards is the weight, what is opposing is the tension. So these are the two equations that we have. So if you plug in there, we know its mass is 50 g minus t. So what is our goal? Our goal is to find the acceleration. So what we can do is we can get the tension from the first equation, which is 40a, and plug in at that point. So what we are going to have is 50a being equal to 50 g. Let me write that just down here. I can just remove that. Okay, so we have 50a being equal to 50 g minus our tension, which we are saying our tension is 40a. Okay, coming from that equation. So making our acceleration to be the subject, that one is supposed to go the other side, which is going to be 50a plus 40a is equal to 50g. So if you factorize your a from the first from the left hand side, you have your a, then the brackets, or if you add them, we are basically going to give you a 90. So you have 90a being equal to 50g. So 50g is basically what? So our a is going to be 50 multiplied by 9.8, which is 50g, divided by our 90 there. So 50 multiplied by 9.8 divided by 90. So basically our acceleration in such a case, what we're going to find is basically a being equal to 5.4 meters per second squared. And that's it for this question. So if I ask you to find the tension, all you have to do is just go back to this equation. You'll be able to find your tension in such a case. Okay. The next question says, a 20 kilogram box is dragged across a level floor with a force of 100 newtons. The force is applied at an angle of 40 degrees above the horizontal. If the coefficient of kinetic friction is what is the acceleration of the box? Okay, let's try to draw the scenario that we have. So we have the level floor there. Then we have what? So we have a box. So we have a box there. So what is this box? What is happening to this box? So there is a force of 100 newton. So the force is applied at an angle of 40 degrees above the horizontal. So there is a force being applied there, and it's 40 degrees above. Okay. What else have we been taught? So the magnitude of that force is basically, so let me draw it a bit down so that you're able to see. So it's somewhere there. Then that force is 40 degrees above the horizontal. Then the magnitude is 100 newtons. Okay. That's what we have there. Then what are they saying? So they are saying the force is 100 newtons. So the force is applied at an angle of 40 degrees above the horizontal. If the coefficient of kinetic friction is 0.32, so we have friction in this case, which is opposing motion. Okay. So what is the acceleration of the box? So this question is very, very simple. All we have to understand is what are we studying. So we are kindly studying horizontal motion here. So this box is moving to the right hand side. So if you look at the force that is applied there, we have to get the component that is making it to move towards the right direction. So basically the force that is going to make it move, that is going to be 100 cos 40. From our vectors, we know that the x component is basically given by that. So that is basically the force that is going to be making it to move towards what? The right hand direction. So what do we know? We know that the net force is basically given as the force applied subtract the opposing forces, which in this case what we have is the force of friction. So if you look at the net force, it's going to be given as a product of the mass and also the acceleration. Then the force applied, in this case we are saying it's the x component of it that is making it to move in the x direction. So it's 100 cos 40. Then the force of friction, what did we say? So we say the force of friction is basically given to be mu k, which in this case is 0.32 multiplied by the normal force. So now let me explain how you find the normal force in this case. So what did we say? Basically, initially we say the net force is going to basically, when there is no force in the y direction, we said the normal force is basically equivalent to what? It's equivalent to the weight, which is mg. So now in this case there is a y component of that force, okay, which is mg sine theta. So we have mg sine theta. Okay, so what you need to understand is that the normal force basically gets to support the weight of the object. Okay, so the normal force gets to overcome the weight of the object. So now in this case there is kind of a force that is helping it to overcome the mg there. So what are we saying? So we are going to say that our normal force in this case, basically, under a normal case, we know that the normal force is basically equivalent to mg. So now it's basically supposed to be equivalent to or support the weight force. But in this case there is a force that is helping it. So basically we will add the force helping it, which is the y component of that force. So the y component of that force is basically going to be what? Its force, which is 100 sine what? So it's basically 100 sine 40 degrees. So we have 100 sine 40 degrees plus the normal force. This is basically supposed to be equal to mg. So what we need to understand is whenever you have a force that is acting upwards, it reduces the normal force. Whenever you have a force that is pulling downwards, it increases the normal force because the support required to overcome it will be greater. But in this case where you have a force pulling upwards, the y component is going upwards, it reduces the normal force. So in summary, the normal force is basically going to be given as the difference of the weight force and the y component of the force, which is 100 sine 40. So if you get your calculator there and plug in the values that we have in this case, what will be our normal force in this case? So our normal force is going to be, so we are saying mg, which is the mass. In this case the mass is 20 multiplied by 9.8 subtract 100 sine 40. So what we have, our normal force is basically 131.7 newtons. So now that we have our normal force, we can now plug in into our equation there and be able to find our acceleration. So I can now remove this because we've already explained that. So that is our normal force. So for our mass there, our mass is basically 20. So we have 100 cos 40. Our coefficient of friction is basically 0.32. And our normal force is basically what? Our normal force is basically 131.7. Okay, so our acceleration is basically going to be given as 100 cos 40 minus 0.32 multiplied by 131.7 divided by what? Divided by 20. So grab your calculator there. 100 cos 40 subtract 0.32, which is the force opposing motion, divided by 20. So what we have as our acceleration in this case is basically 3.6 meters per second squared. So take note of the normal force calculations, because that was the only tricky part that we had in this case. Okay, so whenever you have sent a box there on the level, so whenever you have a force pulling upwards, provided it has got the y component, so whenever you have a force in the y component pushing upwards, it reduces the normal force. So whenever you have a force pulling in downwards there, it will increase what? It will increase the normal force. That's the way it works. Okay, another question there. Two masses are connected by a light cord over a frictionless body as illustrated. The coefficient of kinetic friction is 0.18. So in this case, it's a bit different because we have what? Because we have the friction there. So we have friction. So the first question is, what is the acceleration of the system? The second part, what is the tension? The other part says, assume that the system starts to move. For what values of will it not start? So this was supposed to be for what values of the coefficient friction for static friction will it not start. So let's start. So the first part of the question is asking us to first of all get to find the acceleration. So remember, we're supposed to come up with a relationship on each mass. So if you look at the mass that is down there, what is making it to go downwards is mg. What is opposing is the tension. So what is the relationship in such a case? So we are saying the net force is basically a difference between a force leading to motion, which in this case is the weight, subtract what is opposing is the tension there. So we have that equation there. So what is the net force? The net force is going to be given as a product of the mass, which in this case we are saying is 3.2. So we have 3.2 multiplied by the acceleration, then mg there, so it's still our mass, 3.2 g, minus tension there. So we can make tension to be the subject. So T is going to be 3.2 g minus 3.2 m. So we have our first relationship for the mass going downwards. What if you look at the mass now that is going upwards there? How basically is it going to be? The one that is along the table or on the friction, on the table where there's friction there, this one, the 5 kilogram, how is it going to be? So we are saying what is making it to move is basically the tension force. So the net force, its net force is going to be a product of its mass, 5 multiplied by A, basically equal to the force making it to move is the tension. What is opposing is the friction force. So this is how different this one is as compared to the other questions that we looked at earlier, because of the friction. Okay, so we have 5A. So the tension, then the force of friction we said is basically given as the coefficient of friction multiplied by what? The normal force. So in this case, the normal force is basically the weight, which is mg. So its mass multiplied by g, 5g, like that. Okay, so that is basically the important information to help us get to find the values. So to find our acceleration, we have to plug in now the tension coming from the other equation. So 5a is equal to, for our tensions we have 3.2g minus 3.2a. That's what we have for our tension part, that part. So we are remaining with minus what? Minus mu k multiplied by 5g. Okay, so let's try to substitute now and see what we're going to find. So we have basically have 5a. So this one can go the other side to be plus 3.2a is equal to, so we have 3.2g minus mu k 5g. So that is basically our equation that we have. So 5 plus 3.2 is what? So basically what we have here is 8.2. So I have 8.2a is equal to, so 3.2g, our g is 9.8. Okay, So we have that part minus, what is our mu k? Our coefficient of friction is 0.18. Then what is our 5g? 5 multiplied by 9.8. So grab your calculator there and plug in the values. We see what you're going to have. So we have 8.2a is equal to, so 3.2 multiplied by 9.8 subtract 0.18 multiplied by 5 multiplied by 9.8. We have 22.54. So you divide by 8.2. So what we have as our acceleration is basically 2.75 meters per second squared. So that is how you get your acceleration. For your tension, you go back to this other equation. So our tension is going to be 3.2 multiplied by 9.8 subtract 3.2 multiplied by the acceleration. So let me write that down due to lack of enough space. Well, so we have minus 3.2 multiplied by 2.75. So basically that is going to be 3.2 factorized 9.8 minus 2.75. So what we have as our tension in this case is basically 22.56 newtons. And that's how you do your calculations. Okay, so for the last part of the question, basically it's asking us for what values of there's supposed to be static friction there. So basically when you talk about static friction, it's a friction that opposes something to start moving. So this is the system that we had. So basically how do you get to approach it? Okay, so if this box is not supposed to start moving, what does that mean? So remember, if we go back to our equations, what did we say? So for the first part of the equation, that mass on top there, we said the equation that we have is basically, we are trying to take an assumption of the net force, fair? Okay, our net force is equal to, then we said what may make it to move is the tension. Then what is opposing is what? What is opposing is the friction force. So we use static friction. Okay. Then on the other side, what do we have there? On the other side of the equation, what we have is this is what is making it to go down is basically, so say the net force, it has also its own net force. Then what is making it to move is the mg, the weight force, downwards. Then what is opposing is the tension. So if you try to simplify that, its net force is going to be 3.2 a. Then our its mg is going to be 3.2 g minus the tension there. Okay. So then what do we have for the net force? So for the net force for the first part is going to be 5a. So we can now say T minus, so for static friction is actually mu s there, which is static friction, or coefficient of static friction, which is basically the value that they're asking for, multiplied by the normal force. So the normal force is still mg, which is 5g in that case. Okay. So before you even get to substitute, okay, let's work it out just that way. We see what we're going to have. Okay. So I want to find the value that can make it not to move. So we have 5a is equal to T minus mu s 5g. Okay. So when you look at the right hand side again there, the one that is down, we can also make tension to be the subject. So if you make tension to be the subject, 3.2g minus 3.2a, that's what we have there. So we can plug in. So it will be 3.2g minus 3.2a. Okay. I've plugged in there. At that point where we have our tension, I've put 3.2g minus 3.2a. So now we have minus mu s 5g. Okay. So our goal is to find the static friction there. Our goal is to find the static friction. Okay. So if we are to have basically no motion or yeah, if we don't expect to have any motion or any objects to move, meaning that there's not supposed to be any acceleration there. So meaning that if there's no acceleration, that is supposed to go away, and this can go the other side, which is going to be minus 3.2g being equal to minus mu s 5g. So we are able to see that g is common and it can cancel out. So basically we now have, so the negative can cancel out, it will become positive. So we have 5 mu s being equal to the left hand side, there is 3.2. So our minimum coefficient of static friction, which is possibly can avoid it moving, is basically 3.2 divided by 5, which is basically 0.64. So that is how you approach a question. Okay, so that's it for this video. Watch out for the next video where we're going to look at these forces on an inclined plane. Thank you very much.